Class example 3.54. A particular strong investment fund promises investors an annual return of 12%. Assuming this growth rate is obtained, determine how long it would take for a $10,000 investment to grow to $25,000. So in this question, we're given the final amount. We want it to grow to $25,000. So that's what we want to end with. And our initial amount is going to be $10,000. Now, careful in this one because our multiplier will be 1.12. And you can think about that as being 1 plus the growth rate. And in this case, the growth rate was 12%, but written as a decimal, 0.12. So in the end, it's 1.12. And just to reinforce that, you can see here, if we went $10,000 times 0.12, so 12% of $10,000, well, that's $1,200. And if you added that to our initial $10,000, then you would get $11,200. But kind of a quicker, easier way of doing that would just be to multiply 10,000 by 1.12. And that will get you to the same place. Now, for our t value, or in this case, p on your equation, this is going to be happening every 1 year. So we could write a 1 with a fractional exponent if you like, but really you would just write this as t. All right, so now we just need to solve for the amount of time for our $10,000 investment to grow to $25,000. So we're going to be using logarithms to solve for this. So first step, we're going to want to isolate the power term. So divide both sides by 10,000. Now, at this point, you could take the log of both sides. That would work just fine. The other way of thinking about it is that we could just convert this exponential form into logarithmic form. So log base 1.12, so that's the base in the exponential and the base in the log, of 2.5 is equal to the exponent, because logs solve for exponents. So we get 8.085, or approximately 8.09 years. Now again, if you have more of an old school calculator, you would need to use the change of base formula. So that would be log 2.5 over log 1.12. Now we can check our work. We can put that number back in. We can see, okay, if we actually put in 8.085, a little bit less rounded in this case, do we actually get 2,500? And yeah, we get close. We get very close. And the reason why it's not exactly the same is because we had to round this. This was an irrational number. This would have actually went on forever. So it was never going to be exactly right. Now, we can also verify graphically. So we could write y1. So this part of the equation, we can type it in as y1. And 25,000 is y2. Now, remember the x value, the x max in this case, if we want to actually see where they intersect, the x is really our time going across here. So if you're trying to figure out what kind of like is a reasonable x value, well, remember it's not going to be like 10,000 or anything like that, because this is an investment that we're hoping to see in our lifetime. So in this case, 20 would be like somewhere close. It could be 40, it could be 50. We're in the right ballpark. You just need to be able to see it. And then our y max, we chose 26,000 just because that's a little higher than 25,000, just so we can actually see where they intersect. Now, the other method we could use the solve function. So this is under your catalog button on your calculator, bottom left on the calculator. And remember how this works. This first section needs to be set equal to 0. So we have to rewrite the equation, bringing the 25,000 over, setting it equal to 0, because your calculator assumes that this first parameter means it's equal to 0. And then comma, and then the x variable, meaning that we're solving for x. And then the next part of it would be guess. So you could actually put like anything in there, because the guess is saying, what do you think the solution is close to? So if you put anywhere around 20 or 10, it actually wouldn't matter, because there's only going to be one solution anyway, so it'll find it. All right, now just to recap how this would work year by year. You can think about after 1 year, if we had $10,000 and we increased it by 12%, that would be 10,000 times 1.12. So 11,200. And then we take that amount, right? So answer, we just bring it down, times 1.12. And increase, that's after 2 years. After 3 years. Now, another way of showing after 3 years, just from the beginning, would have been 10,000 times 1.12 to the power of 3. That would have been after 3 years. After 4 years, so to the power of 4 for our time. And then you could write it, if you were looking for to the power of 8. So now comparing that, so this would be after 8 years, we get $24,759. Well, that's in the right ballpark. Our answer was 25,000. And we figured it was 8.09 years. So it makes sense that we were just under 25,000.